Hello, good morning everyone. I'm Dr. Harika Kishore on behalf of Vista's Learning. I'm here as your biology educator. V-Learning, it's an online education platform which works with an ideology of providing quality education for all. Visit our website www.v-learning.in where you're going to get an access for all the live classes, recorded sessions, concept videos, study materials. Moreover, you're going to get this lecture notes in the form of PDFs. Get your acquaintance with all the channels available and make sure to subscribe to the channel Vista's Learning Class 11 and 12. If you find this session useful and interesting, click on the like as well as share this session with your friends. And also click on the bell icon such that you are going to get all the upcoming video notifications. Now, let's start our today's session. We have been discussing about the chapter environmental issues, which comes under the unit ecology, right? Now, in the previous session, we discussed about the water pollution and the control measures. So here in this class, in this session, let's discuss about the integrated wastewater treatment. So here integrated is a coordination where we use the mixture of two methods together such that it is useful to treat the waste water. So here let's start. We're going to discuss about a case study of integrated. As we already mentioned, integrated is a mixture of two procedures. Here, we are using both natural way as well as artificial treatment methods to treat this wastewater, integrated wastewater treatment. So, as we already discussed about the water pollution and its control, right? To control and also to safeguard our natural resources, we already understood how it is important to dispose the treated wastewater. First, the wastewater has to be treated, then only it is allowed to dispose into the natural resources. Thereby, we can reduce the pollution that is created to this natural resources. And in order to safeguard these natural resources, government of India have also passed an act, and that is Water Prevention and Control of Pollution Act, that is in the year 1974. So let's understand about this integrated wastewater treatment. Wastewater, including sewage, can be treated in an integrated manner, integrated coordination of more than two procedures, two processes. Here we are mixing the two different processes such that we can effectively treat this wastewater. So here integrated manner by utilizing a mixture, that is what we are considering this method as an integrated method. Mix of artificial and natural processes. Here we are using both artificial as well as natural processes to treat this wastewater. An example of such an initiative is the town of Arcata, situated along the northern coast of California. Let's understand about integration of both artificial as well as natural processes. So here, collaborating with biologists from State University, and that is called as Humboldt State University, and the townspeople created an integrated mixture, coordinated procedure, that is integrated wastewater treatment process within a natural system. As we already discussed about the sewage water treatment, we have discussed about the two major treatments, that is primary treatment and secondary treatment. In the primary treatment, we uses two methods like sedimentation and filtration, right? And once the sedimentation and filtration done, the primary effluent is then subjected to the secondary treatment. And here in the secondary treatment, we make use of the microorganisms. That is what we consider this also as a biological treatment of the wastewater. So the same way, first procedure, that is primary treatment, where we are going to use methods like sedimentation and filtration. Sedimentation, filtration, we already discussed in the previous class itself. Here also, we have been using this same sedimentation, filtration and chlorination. Let's take a look at it. The cleaning occurs in two stages, where the primary method is same as we already used in the conventional methods like conventional sedimentation, filtration, that is filtrating, and chlorination. Chlorine treatments are given. Now, whatever the effluent, what we consider as a primary effluent, the sewage is passed through a conventional sedimentation, filtration and chlorination. Now the leftover effluent is, that is primary effluent, right? So after this stage, after this conventional stages, where it includes a method like sedimentation, filtration and chlorination. Lot of dangerous pollutants, we already know. Pollutants are nothing but the elements, molecules, substances which are present in the pollution, and exposing to these materials, to these substances, to these pollutants will cause us a harmful effect towards the health of an living organisms. And that pollutants like heavy metals, dissolved heavy metals still remains in the primary effluent. The primary effluent is a result of sedimentation. Sedimentation is allowing to stand for a particular time of period. So here what happens, whatever the debris or the pebbles, small stone, sand, clay, that will sediment. Now after that, we'll take off all the bottom sedimented particles. Now whatever the leftover present, what we call as a supernatant, is again subjected to the series, that is sequential filtration. Filtration after filtration, that is what we consider as a sequential filtration. And after that, chlorination. Still, the primary effluent contains dissolved form of, that is heavy metals. We need to treat this. We need to reduce the content of the dissolved heavy metal which is present in the primary effluent. Then to combat, that is to reduce, to fight against the dissolved heavy metals which are present in our primary effluent, there is an innovative, that is new approach. New approach was taken, and that is the use of living organisms like plants, algae, bacteria. Let's see. Similarly, while we are discussing about the usages of the microorganisms in treating the sewage water, also we discussed about anaerobic bacteria, aerobic bacteria, right? So here, the aerobic bacteria will just feed on the organic matter which is present in the sewage. Here also, that organic matter has to be dissolved, consumed, assimilate by a set of living organisms, and for that living organisms we are providing the habitat by means of marshes. So the biologist develops a series of 6 connected marshes, means waterlogged areas like wet areas over 60 hectares, and that we call it as a marshlands. So these marshlands are now going to act as a suitable habitat for a different biodiversity in the form of plants, algae, fungi, bacteria. So now here, appropriate plants, algae, fungi and bacteria were seeded, were allowed to grow in the habitat. That habitat is your marshland. Into the area, and this area is a wetted, waterlogged areas, that what we consider as a marshes. Now, so here, which neutralizes? That means when the organisms what their organisms, which includes bacteria, algae, fungi, bacteria, which are growing in the marshes. These plants, algae, fungi, or bacteria are going to neutralize, absorb, use, that is assimilate, take the pollutants. Pollutants are present in the primary effluent. Whatever the solid waste that is passing through the primary treatment, once the primary treatment is done, still the water contains, that is the wastewater still contains the dissolved form of the heavy metals. For that, we are allowing this wastewater to flow through the marshlands. And here in the marshlands, these are the suitable habitat for the growth of plants, algae, fungi, bacteria. All living organisms starts to neutralize, starts to absorb, and starts to assimilate, take use of this pollutants, which makes the concentration of the pollutants that are present in the wastewater to reduce a lot. Now, hence, as the water flows, we allow the water to flow through this marshlands. Through the marshes, it gets purified naturally. That is what we consider. Both naturally it is getting purified, and the previous step where we are employing some of the techniques, some of the methods like sedimentation, filtration and chlorination. All these are artificial processes. So we are using the coordinated method, and that is called as integrated method. Integrated wastewater management, where we are using both artificial methods as well as natural methods. Right? Now, so here the marshes not only will provide a suitable place, suitable habitat for the growth of plants, algae, fungi, bacteria, which are going to neutralize, absorb and assimilate whatever the pollutants which are present in the polluted water. Meanwhile, these marshes are providing a great biodiversity, right? The marshes also constitute a sanctuary, that is natural reserve with a very high level of biodiversity. So not only our water is getting purified, but also this habitats are providing, this marshes are providing a wonderful habitat, which finally leads to a increase in biodiversity. Biodiversity in the form of fishes, animals, birds that now resides here. Here in the sense marshlands. So the citizens called the citizens group, we call it as a FOAM, which abbreviates as Friends of the Arcata Marsh. Friends of the Arcata Marsh. So this marshes we are using to treat the wastewater in a natural way, are responsible for the keep up, and this is the group of the citizens who are responsible to keep up and also safeguard this wonderful project in the sense that is an integrated wastewater management. Integrated wastewater management is a program which has been keep up and also safeguarded by the group of the citizens, and that group what we call it as a FOAM, that is Friends of the Arcata Marsh. So now, so this is an case study. We understood about the integrated method of wastewater management, where we are mixing up for two procedures. One is natural procedure and other one is artificial procedure. Artificial procedure where we are allowing a water to get sediment, to get filtered and to get chlorinated. Once these steps have been finished, now the water has been passed to the marshes. And as the marshes are providing a habitat for the growth of animals, birds and fungi, algae, plants, bacteria, these are going to feed, that is neutralize, absorb and also we can say assimilate the pollutants which are present in the wastewater, thus making this water purify naturally. So here at this time, like all these times we have assumed, we thought like that removal of the waste requires water. Always removal of the water, removal of the waste or cleaning of the waste needs water. That is our assumption, which finally leads to the creation of sewage. Sewage is a wastewater. If you use water to clean something, whatever the water which is coming now, we consider it as a sewage because it contains impurities, right? Now, but what if water is not necessary to dispose of human waste like excreta? We know that most of the water has been used while flushing, while using toilets. What is another alternatives we can use in such a way to reduce the usage of the water? And also, effectively, we need to clean up this human waste. Let's take a look at it. The solution for this is the usage of eco-san. Eco-san. Ecological sanitation. Ecological sanitation, which is a sustainable system for handling human excreta and using dry composting toilets. So here is a usage where this is the procedure, this is the operators where we can use here very effectively and economically and also hygienically we can convert this human waste into fertilizers. As it is coming from the natural source, we call it as a natural fertilizers. Here is the creation of the natural fertilizers, which are the very good alternative for the usage of chemical fertilizers, and moreover we are effectively disposing the human waste. So here, ecological sanitation. Let's know something about this ecological sanitation. Ecological sanitation, in short, we call it as a eco-san. It is a practice of hygienic, efficient and cost-effective, economical solution for the human waste disposal. Here, one thing, we are converting human waste into fertilizers, natural fertilizers, and the second thing, we are effectively disposing this human waste. Now, the key point to note here is that with this composting method, human excreta can be recycled, converted into resources. Which resources is that? As a natural fertilizer, which is a good compensator of the chemical fertilizer, which reduces the need for the usage of chemical fertilizers. So, the first and the foremost thing here is we are using the human waste for recycling and we are converting this into natural fertilizers. Thereby, we can reduce the use of the chemical fertilizers. And also, this are real-time working, and we can see there are working eco-san toilets in many areas of Kerala as well as Sri Lanka. Here is a dual advantage. One thing, we are producing the natural fertilizer, thereby we can reduce the use of the chemical fertilizers, and we also effectively disposing the human waste. Now, let's move towards a solid waste. Up to now, we discussed about the water pollution and control, right? Let's take a look at solid waste. Solid waste, simply anything which goes into the trash is solid waste, like plastic, paper, cotton, fiber, leather, food waste, all these things which we dump into the dustbin is a solid waste, right? Solid waste refers to anything, everything that goes out into the trash. It may be plastic, it may be like glass, metal, right? And even we can say some of the cloth fibers, if the waste is coming from the hospitals, lot of cotton will be your waste material, used cotton, right? So here, municipal solid waste or waste which comes from the homes, office, stores, schools, hospitals, etc. Hospital, even used syringes, used saline bottles, all will add up to the plastic, waste plastic, that are collected and disposed by the municipality, right? Okay, the municipal solid waste generally comprises, just now we mentioned, paper, food waste, plastic, glass, metals, rubber, leather, textile. Used leather pieces, textiles, fiber, used cotton, syringes, all this or the waste that we daily add to the bins, that we can say the waste which is coming from the houses, hospitals, offices, right? So here, what is the best way to reduce the volume of this solid waste? One is burning it. Burning definitely reduces the volume of the waste. And here, although it is generally not burnt to completion, complete burning is not possible. Therefore, we are going to dump, that is open dumps. And open dumps often serves as a breeding grounds for the rats and flies. We know that flies contribute so many infectious diseases, that is the infection passes from one individual to the another individual. Again, this is a problem. So what is the best alternative for this open dumps? If you dump this solid waste to the open lands, definitely it is going to cause again another problem. That is, the best example here is these lands are going to act as a breeding grounds for the rise of rats as well as flies, right? So what will be a better alternative of this open land dumping? That is landfilling. Sanitary landfilling were adapted as a substituent for the open burning dumps. So here, in a sanitary landfills, where the lands are digged to create the trench or depressions, and these depressions are filled with the solid waste, then again they are covered with a dirt. This is what happens in the landfill. So here, waste are dumped in a depression, a trench, after compaction. Compaction is reducing the gaps that are present in the solid, that is soil particles, by removing the air gaps. That means we are making a spaceless, compaction and covered with the dirt every day. But this is also not going to work as a solution for the long term, because landfills are also not really much of a solution, since the amount of the garbage generated, especially in the metros where the population is more, has increased so much that these sites are getting filled too fastly. Therefore, again we have to look after another alternative. Here, also there is a danger of seepage, leakage, that means penetrating this pollutants and added up to the underground natural resources. Again, it is going to pollute the water which is present in the underground. Also, there is a danger. Seepage means penetration, going deep into water, going the pollution, which is pollutants which are present in the solid waste, are going to drain, are going to move through the gaps, and they are going to add up to the water which is present in the ground level of chemicals, etc. From these landfills polluting the underground water resources. Again, we have to check this circumstance. We shouldn't allow this to happen. We have to avoid the situation. We don't want to pollute our underground water resources. Then what is an other betterment than the solution? So here, a solution to all this can only be human beings. We have to think sensitive, and we have to carry our own eco-friendly bags for getting our provisions or the food or like whatever we are carrying to the home. Now, becoming more sensitive to the environmental issue is very, very important. Now, all waste that we generate can be categorized, can be divided, can be distinguished into three different types. What are they? Biodegradable, non-biodegradable, recyclable. So, biodegradable waste which can be degraded easily, and the non-biodegradable is the waste which has to be taken care of proper disposal. And recyclable waste can go for the recycling. Now, so here it is important that all the garbage generated is sorted, separated, separated into above categories, whether it will come in a biodegradable form or non-biodegradable, or it is a recyclable. That is, we can send it to the recycle. What can be reused, that is recyclable form, reused or recycled, should be sent to the, should be separated out, and it should be separated to the recycling industries. Our kabadiwala and rug pickers who collects the garbage collectors, do a great job for separation of the materials for recycling. They actually find their livelihood, and they separate all the garbage such that it can be divided into solid waste or the liquid waste. And the second thing is, in the solid waste, again they'll categorized into biodegradable, non-biodegradable and recyclable forms. So the whatever the waste which comes under recycle, that has to go for the recycling. Now here, the biodegradable materials can be put into deep pits, right? We dig the pits and we'll keep this biodegradable because they can be easily degradable, decomposed by the activity of the soil microbes, right, in the ground, and we left for the natural breakdown. Natural breakdown happens by means of the soil microbes, that is the microbes which are present in the soil will decompose. While we are discussing about the topic of decomposition, we have discussed about how the decomposition happens in the presence of the soil bacteria, soil microbes, such that these are break down and be mixed up for the to increase soil fertility, right? That leaves only the non-biodegradable. So the solid waste has been already differentiated into three categories. One is recycling, which goes for the recycling, and biodegradable are kept in the deep pits of the ground. Thereby, it is subjected to the further natural breakdown. Now, we are left with the non-biodegradable solid waste, right? Non-biodegradable, and that has to be disposed of. The question here is how we dispose. How we dispose this non-biodegradable solid waste. So here, we need to first reduce our garbage generation. Should be a prime goal. Reduction. How can we reduce the creation of the garbage? One thing, we are increasing the use of non-biodegradable product. We can reduce the use of the non-biodegradable products and increase the use of the biodegradable products. Just pick any ready-made packet of any good quality eatable, say it like whatever, fruits, milk, biscuits, chocolates, any eatables such as biscuit packet. The study of the packaging, do you see the number of protective layers? We might have come across with a tetra protective layer, out of which at least one will be the plastic, right? Note that at least one layer is of plastic. And this is the one which is creating lot of damage by abstracting the penetration of the water into the deeper layers, thereby affecting the level of the groundwater which is present. So we have started packing even our daily use products like milk, water in poly bags, polythenes, right? In cities, fruits, vegetables can be brought packed in beautiful polystyrene plastic packaging. We pay so much, and what do? Like, we are contributing heavily for the addition of the environmental pollution. By paying so much of money, we are heavily contributing to the environmental pollution by adding all this plastic to the environment. So this is what we need to think over it, and state government across the countries are trying to push for reduction in the usage of plastic and also to encourage the use of eco-friendly packaging. Eco-friendly packaging we can do by our bit by carrying a cloth bag or other natural fibers like jute bags, carrying bag, and when we go shopping and we can refuse taking these polythene bags. or we can also use this brown packaging or the brown paper bags to carry a small amount of provisions what we get to the house every day. Now, hospital wastage. So we are in the process of understanding how we well dispose this non-biodegradable material, non-biodegradable solid waste. Hospitals are the major places where we are going to get a lot of plastics, right? So here, hospitals generate hazardous, dangerous, because the chemicals which comes from expired medicines, expired like tablets, are going to be acts as a very dangerous, hazardous waste that contains disinfectants and other harmful chemical. So, and also it may contain some pathogenic microorganisms too, because the waste which is coming from the hospital, maybe it is blood or maybe the human samples like serum, which is a rich source for the growth of the microorganisms. And all the microorganisms which grows may not be of non-pathogenic types. Some may be pathogenic types. Because of this reason, the pathogenic microorganisms do occur, do exist in the waste that is coming, that is a garbage which is coming from the hospitals. So here, such waste also requires careful treatment. Without the proper treatment, we are not supposed to fill it to the, or just add to the dumps or the landfills. First, it has to be treated properly. And disposal. Before disposal, proper treatment has to be given to the hospital waste, because hospital waste will contain so many chemicals, so many harmful chemicals, hazardous chemicals, that is dangerous chemicals, as it may have a much more possibility of containing pathogenic microorganisms. The use of this is the one. Incinerators. Incinerators are the operators which are used to bunt the solid waste. And that bunt is very complete such that the solid waste will remain with ash. The use of the incinerators is crucial, important to disposal the solid waste. Importance to this solid waste is given because of the hazardous, harmful, dangerous chemicals that are going to be present in the hospital waste. Because of that reason, the hospital waste are not to be disposed directly to the landfills or the ditch or the ground pits. Before that, we have to incinerate it. Incinerators are the operators which are useful to burn this waste, harmful waste, into ashes. Now, irreparable computers which cannot be rectified, which cannot be repaired. These computers or the other electronic goods are known as electronic waste or e-waste. This is another important non-biodegradable waste that that comes from this e-waste. So, e-waste are buried in landfills, or this is also subjected to incineration, burned to ashes. Over half of the e-waste that is generated in the developed world are exported to the developing countries, mainly to China, India, and Pakistan, where metals like copper, iron, silicon, nickel, and gold are covered using or recovered during recycling processes. These are all the metals that can be recovered during recycling process. But here, unlike the developed countries, we have specifically built facilities which in the developing countries, they will have a very specifically built facilities for all this recycling process, for recycling of e-waste. Recycling in developing countries often involves manual participation, manual separation, manual picking, manual separation of this recycling material that is present in the e-waste. While the persons or the workers are working to separate this recycling material which is present in the e-waste, they are exposed. They are subjected to exposing workers to the toxic substances which are present in the e-waste. In the developed countries, we find very specialized, specific facilities that are provided for separation of this, or picking up of this recycling waste which is present in the e-waste. But all this in the developing countries happens by using the workers. We use the workers to separate this manually. While they are separating, there is a much more chances for these workers who are working are going to subject, are going to expose to the chemicals that are present in the e-waste. Recycling is the only solution for the treatment of e-waste, provided it is carried out in an environmentally friendly manner. Now, environment friendly manner, that is eco-friendly manner. Now, let's have a case study of remedy for plastic waste. Here, a plastic sack manufacturer in Bangalore has managed to find an innovative solution for this plastic. They use this plastic to lay the roads. And for this thought, it is worth mentioning about a person. Let's have a discussion about this. So here has managed to find an ideal solution, innovative solution to the ever increasing problem of accumulating plastic waste. This usage of the plastic has been increasing, and it is ever increasing problem, which leads to the lot and lot accumulation of this plastic waste. So here, Ahmad Khan, aged 57 years, has been producing plastic sacks for 20 years. About 8 years ago, he realized that how much this plastic waste is going to create a harm to the environment, that plastic waste was a real problem. He actually realized the real problem comes from the plastic wastage. So here, polyblend, a fine powder of recycled modified plastic was developed then by his company. And this polyblend, it's a fine powder of recycled modified plastic. This mixture is mixed with a bitumen, and that is used to lay roads. So here, in collaboration with RV, College of Engineering, and the Bangalore City Corporation, Ahmad Khan proved that blends of polyblend and bitumen, when used to lay roads, enhances the bitumen's water repellent properties. Thereby, it helps to increase the road life by a factor of 3. Now, that means the road life is going to be increased. The raw materials for creating the polyblend is any plastic film waste. Any plastic film waste can be used as a raw material for the formation of the polyblend, and this blend of the polyblend and bitumen is going to be act as a source for laying roads. Now, it is estimated, so against the price of 0.40 per kg, the rug picker, that is a garbage collector, have been getting the plastic waste can now offer ₹6. Previously the rate was 0.4. Now it is ₹6. Using Khan's technique, by the year 2002, more than 40 kilometers of road in Bangalore have already been laid. And the water repelling capacity of the bitumen has been enhanced by the blend of this polyblend. That is what the blend of polyblend as well as bitumen is used to lay the roads. At this rate, Khan will soon be running short of plastic waste in Bangalore to produce polyblend. Now, thanks to innovation like polyblend, we might still avoid being smoothened by plastic waste, right? So that is it for today's session. We have been discussed about air pollution and its control, water pollution and its control. By now, we also finished in this session about the solid waste, right? In the coming up session, let's meet up with the next coming up topic, right? Until then, keep learning with We Learning. Thank you.